Hello friends, how are you all? Hope all of you are well. In the previous video, we have described about the mainly about the hydrogen atoms of Bohr's concept and the limitations. Yes, the line spectra. Today we are going to discuss ahead from this the same theory only, the Bohr's model of hydrogen atom and its limitation, but we have to understand with the concept. Today I will just show you with the NCERT textbook. First of all, you have to see that what it's written in the NCERT textbook. If you are not able to understand, then please drop it down into the comment box section. So let's start NCERT textbook, chapter 2, structure of atom. As already I had informed you about the emission spectrum and absorption spectrum. After getting the value of h nu, especially about the energy gap, delta E is equal to, have you remember that formula, delta E is equal to E2 minus E1, or you can say that final upon initial, how the electron jumps from one orbit to another orbit after the absorption and emissions of energy, right? So here you can see, as it is written here, the spectral lines are expressed in the terms of wave number. Spectral lines means the lines which are specially colorful, so they are expressed in the terms of wave number. The visible lines of the hydrogen spectrum obey the formula wave number is equal to 109677 into 1 upon 2 square minus 1 upon n square centimeter inverse, where n is an integer equal to the greater than 3, that is n is equal to 3, 4, 5. See, first of all, already I had informed you about the Bohr's model for hydrogen atom. As we have seen, what was the formula of delta E? After getting the value of delta E, we have compared with E is equal to h nu and we have find the value of nu, right? All of you have remembered that concept? If you have not remembered, then just go to your NCERT textbook and read these two things, emission and absorption spectra, and after then the line spectrum of hydrogen atom, right? So after getting this information, now we are moving towards this Balmer series. As here, wave number is equal to 109677 into 1 upon 2 square minus 1 upon n square, where n is equal to 2 plus 1 only. Remember, means when this line will fall in the second series. Means, as already I have told you about the energy levels, first energy level, second energy level, third energy level, fourth energy level, fifth energy level. When the spectral lines will fall into the, as for example, n1 is equal to 1, then it will fall in the second, 2, 3, 4, n2 will be 2, 3, 4. If n1 is equal to 2, especially for the Balmer series, then the n2 will be 3, 4, 5, as it is written also. So the series will be described into the formula of Balmer series, and the Balmer series of lines, the only lines in the hydrogen spectrum which appear in the visible region of the electromagnetic spectrum. Here there was a Swedish spectroscopist, Johnson Rydberg. He had noted all the series of the hydrogen spectrum could be described by the following expression: wave number is equal to 109677 into 1 upon n1 square minus 1 upon n2 square. As see, already I had described you in the previous video that how this formula came, n1 square minus n2 square, as we have written from the Rydberg constant. Have you remembered that minus rh into 1 upon n square? After that we have taken the energy initiation and energy final state. After then delta E is equal to energy final minus energy initial, and then we have got this formula. So here the wave number is equal to 109677 into 1 upon n1 square minus 1 upon n2 square. Now here where n1 is equal to 1 and 2, then n2 will be n1 plus 1. Are you getting or not? If you are taking the value n1 is equal to 1, then the value of n2 will be n1 plus 1. As for example, n1 is equal to 1, so n2 will be 2. If n1 is equal to 2, then n2 will be 3. If n1 is equal to 3, then n2 will be 4. Are you getting? Yeah. So after getting this concept, as you can see here, that the value of 109677 centimeter inverse is called Rydberg constant. What is it called? It is the Rydberg constant for hydrogen atom. Actually, after getting the concept of all these spectral lines, actually Rydberg had done the experiment and specially done research on all these series for the hydrogen atom, and as he has seen the first 5 series of the lines corresponding from n1 is equal to 1 2 3 4 5, as he had given the name like Lyman series, Balmer series, Postulates series, bracket series and Photon series respectively. As here you can see in this table the transition states of hydrogen spectrum as shown in the Lyman, Balmer, Postulates series of the transition for hydrogen atom. Of all these elements, hydrogen atom has the simplest line spectrum as the line spectrum becomes. You can see in the Lyman series here, Lyman series, when the n1 value will be 1, then n2 will be 2, 3, and the spectral lines or spectral region will be ultraviolet. In the Balmer series, n1 will be 2, so the n2 value will be 3 and 4, and the spectral region will be visible series. In the Postulates, n1 will be the 3, n2 will be 4 and 5, infrared. Bracket series, n1 will be 4 and n2 will be 5 and 6, infrared series. And Photon, n1 will be 5, 6 and 7, infrared series. As first of all, understand this concept. As you can see this diagram, in this diagram you can see in the Lyman series, each and every energy is falling in first orbit, means n1. Either their value are from the 5th orbit or from the 4th orbit, from the 3rd orbit or 2nd orbit. They are moving towards the 1st orbit. Similarly, in the Balmer, you can see they are going in the 2nd series. As what we have learned in this chapter, that when the electrons get energy, they jump from lower energy to higher energy, and when the energy is emitted, they jump from higher energy to lower energy. As you can see in this figure concept, as from the infinity the electron loses the energy, they come and fall down into the first energy level, that is Lyman series. In the second energy cell means or second energy level, it's Balmer series. Third energy level is Postulates series. Fourth energy level is bracket series, and the fifth energy level is Photon series. So as already I have told you about the concept that what is the value of n1 and n2. You can see this diagram. So just see this video concept, how in the Lyman series the electrons are falling in the first energy level, either from the second, means from any energy level they are going toward the first energy level. So that series is called Lyman series. Got it? As in the Balmer series, what will happen? Where they will fall? They will fall in the second energy level. This is Lyman series. You see, now see in the Balmer series what will happen. You can see they are falling in the second energy level, right? So here you can just see the concept of these second and first energy levels, that Lyman and Balmer series. Now you will see about the Postulates series. How the Postulates series will come? In the third energy cells, not in the first or second. They will fall in the third energy cells, right? And now you will see the bracket series. It will fall in the fourth energy cells. This was Postulates series. Now you can see about the bracket series. You can see they are falling in the fourth energy level, right? And now after seeing the bracket series, you will go towards the Photon series. You can see they are falling in the fifth energy levels, right? So after understanding this concept, now you can see that what will be the value of n1 and what will be the value of n2. After understanding this concept, you can see here there is a diagram. In this diagram, as the animated video I had shown you, similarly here also they have represented the Lyman series, Balmer series, Postulates series, bracket series and Photon series. So rationalize the many points in the atomic structure and spectra. Bohr's model for hydrogen atom is based on the following postulates. First of all, he had described about the principal quantum number. What is principal quantum number? Means energy level or orbits. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. This path are called orbits, stationary states or allowed energy states. These orbits are arranged concentrically around the nucleus. What does it mean? Remember, first of all, just think about the nucleus. In the nucleus, protons and neutrons are there. Now, these electrons are bounded with the electrostatic force towards the nucleus, so they are stationary. Still that if they do not get energy, they will not move in the higher energy level or they will not fall in the lower energy. So electron in the hydrogen atom moves around the nucleus in a circular path in a fixed radius and fixed energy. Means whatever the concepts of electrons around the nucleus in the hydrogen atom they are having, they are fixed. They are always revolving in the fixed radius and fixed energy. This path is only called orbit, and the stationary states or allowed energy states, these orbits are arranged concentrically around the nucleus. The energy of an electron in the orbit does not change with time. However, the electron will move from a lower stationary state to a higher stationary state when the required amount of energy is absorbed by the electron, or energy is emitted when electron moves from the higher stationary state to lower stationary state. What does it mean? The energy change does not take place in a continuously manner. Here, first of all, the things is the energy of an electron in the orbit does not change with time. If you think that as the electron is revolving, so the energy should change, it will not change. As the electron revolves around the nucleus in the orbits, the energy is going to remain the same. But if it absorbs or it emits the energy, then after absorbing the energy, it will jump from lower energy state to higher energy state, and after emitting the energy, it will jump from higher energy state to lower energy state. Got it? Now the second point you can see, as already I have told you about that how the electron will jump from first energy state to second energy. Here there is one main point about the angular momentum. All of you know momentum. What is momentum? P is equal to mv. This thing you have studied in class 9. Just a linear momentum is the product of mass and velocity. Linear momentum is the product of mass and velocity. But what's about the angular momentum? Why angular momentum? Because electron revolves around the nucleus. So that's why here there will be a question of angular momentum. What is angular momentum? Angular momentum is the product of moment of inertia and angular velocity. If anybody will ask you what is angular momentum, just you can say it is a product of moment of inertia and angular velocity. For an electron of mass me, all of you know electron will revolve around the nucleus, so electron will have some mass. You know what is the mass of electron? 9.1 into 10 to the power minus 31 kg. So as the moving in a circular path of radius r around the nucleus, what will be the angular momentum? Angular momentum will be, what here you can see, as already I have told you, it is a product of inertia and angular velocity. So I inertia and this omega is angular velocity. So now what will be the inertia? Inertia you know very well. Here mv square, instead of mv square you can see mass of electron and the radius of an atom, m r square, and me, that's why it's written because mass of electron. And after understanding the inertia, what will be the angular velocity? Angular velocity will be speed, means velocity upon the radius. What is the velocity and what is the radius of an atom, where v is the linear velocity. Now the angular momentum will be, as you can see, inertia and velocity product. So inertia formula is mr square, and the angular what will the product of inertia and velocity? Angular velocity, inertia is mr square and angular velocity v upon r. So what will the formula? R cancel, so will be mvr, right? What will be the formula? mvr. If anyone will ask you what is angular momentum mvr. So now the frequency of radiation absorbed or emitted when the transitions occur between the two stationary states with a differing energy by delta E, means energy gap. First of all, listen, as the electron will jump from lower energy state to higher energy state, right? As the electrons will get energy, as the frequency of the radiation will absorb the energy, so it will jump from lower energy to higher energy state, and as the frequency of radiation is emitted, then it will jump from higher energy state to lower energy state, right? So there will be two energy states. So between these two energy states there will be a difference in energy, so that will be denoted by delta E. And you know very well E is equal to h nu, as we have just seen that intensity is directly proportional to frequency. Yes, So E was directly proportional to nu. E is equal to h nu, as we have read earlier, right? Now here delta E is E2 minus E1, E final minus E initial. So here after getting the formula, E is equal to h nu. So delta E will be also equal to h nu. So nu will be delta E by h, and delta E formula is E2 minus E1, where E1 and E2 are the energies of the lower and higher allowed energy state respectively. This expression is commonly known as Bohr frequency rule. What you have to do, you have to just underline this equation. After underlining this equation, you will remember this formula, as this formula is known as, what is this formula known as? This formula is known as Bohr's frequency rule. Got it? What is Bohr's frequency rule? Directly you have to say frequency nu is equal to E2 minus E1 upon h. This E2 is the higher energy state, E1 is lower energy state, and h is Planck's constant. Now the angular momentum, as we have studied, the angular momentum of an electron is quantized. In a given stationary state, it can be expressed mvr is equal to integral of h upon 2 pi. This nh by 2 pi you are seeing now, it is the integral of h upon 2 pi, and this n is 1, 2, 3 any integers. Got it? So here you can see where mass of electron is the me is the mass of electron, and nu is the velocity, and r is the radius of the orbit in which the electron is moving. Thus an electron can move only in those orbits for which its angular momentum will be integral multiple of h upon 2 pi. What does it mean? Means electron can move only in those orbits whose angular momentum will be integral multiple of h upon 2 pi. That means angular momentum is quantized. Angular momentum is quantized, and the radiation is emitted or absorbed only when the transition of electron takes place from one quantized value of angular momentum to another quantized value of angular momentum. See, first of all, you should know the concept about it, that as the electrons emit or absorb the energy, so electron will be transition. Transition means variable. It will move from one quantized angular momentum to another quantized angular momentum. So the Maxwell electromagnetic theory has not explained about that why only certain fixed orbits are allowed. Understand? Maxwell electromagnetic theory has not explained about, or theory does not apply here, that why only the certain fixed orbits are allowed. If anybody will ask you why the certain fixed orbits are allowed, so you can say here because the electrons can move only those orbits for which the angular momentum will be the integral multiple of h upon 2. Got it? Now, the details regarding the derivation of energies of the stationary state used by Bohr are quite complicated and will be discussed in the higher classes. However, according to the Bohr's theory, see, it is not general thing that in the 11th standard you will get all the informations about that higher energy level and lower energy. As you will move towards the higher classes, as for 12th standard, BSc, MSc, in the chemistry you will get this concept. But till 11th standard, what the Bohr's, whatever the postulate he had described, the detail regarding the derivation of energy of the stationary state used by Bohr's are quite complicated, as we will study in the higher classes, and some of the postulates of the hydrogen atom, as he had told. Now you can see the what are the stationary states of for electrons are the numbers. The stationary states for electron are the numbered. These integral numbers are known as principal quantum number. Means remember, these are the energy levels. What are these? These are energy levels. You know very well, when the electron will stay in the first energy state, it is the first energy level. It will go in the second energy state, second energy level, third energy level, fourth energy level, right? So the radii of the stationary states are expressed as Rn is equal to n square a naught. Now, what will be the radius of that energy? Since this Bohr had explained about the hydrogen atom, so here you can see Rn is equal to n square a naught, where n is equal to 1, 2, 3, 4 as the energy levels. But the value of a naught is fixed, that is 52.9 picometer. As if I talk about the hydrogen, whose atomic number is 1, the radius is 1, you know very well. So now the radius r1 will be 1 square into a naught. So 1 square is equal to 1 only, and a naught is 52.9 picometer. So normally the electron in the hydrogen atom is found in this orbit where n is equal to 1. As the n increases, the value of r will also increase. In other words, the electron will be present away from the nucleus. Means as the number of energy levels will be increased, the distance from the electron to the nucleus will be also increased. Now, the most important property associated with the electron is the energy of the stationary state. As already I have told you, still the electron do not get the energy, it will not jump from the lower energy state to higher energy state. So here you can see as En is equal to minus RH into 1 upon n square. En is equal to minus RH into 1 upon n square, where n is equal to 1, 2, 3, 4. So here, now if I talk about the initial energy state and the final energy state, so what will be the value? You can see here En is equal to minus RH into 1 upon n square. N is equal to 1, 2, 3, 4. So where RH is the Rydberg constant and its value is 2.18 into 10 to the power minus 18 joule. It is the value of Rydberg as the Rydberg had found about the spectral lines. So his value was, earlier I had described you about it, but here as in the Rydberg constant, En is equal to minus RH into 1 upon n square. So here the RH value is fixed, that is 2.18 into 10 to the power minus 18 joule. So after putting the value, if you think about the first energy level E1, okay, that is the ground state. So the energy of the lowest state, also known as ground state, is E1 is equal to minus 2.18 into 10 to the power minus 18 into 1 upon 1 square. Why 1 square? Because we have taken here n is equal to 1. So 1 upon 1, 1 only, as we have multiplied 1 with the 2.18 into 10 to the power minus 18. So minus 2.18 into 10 to the power minus 18 into 1 is equal to minus 2.18 into 10 to the power minus 18 joule. If I talk about the stationary state second, means second energy level, so what we have to do, instead of n, wherever the n are there, we have to put 2. So the E2 will be minus 2.18 into 10 to the power minus 18 into 1 upon 2 square. What is the value of 2 square? 4. So minus 2.18 into 10 to the power minus 18 divided by 4. As you will divide, so it will be minus 0.545 into 10 to the power minus 18 joule. It was for second energy level. So as you have seen here, that what this Niels Bohr had described, he had depicts the energy of the different stationary states of energy levels of hydrogen atom, and this representation is called an energy level diagram. Now just suppose here, when the electrons is free from the influence of nucleus, means now electron is not binded with the nucleus, what will happen? The electron is taken as 0, and the electron in this situation is associated with the stationary state of principal quantum number n is equal to infinity, because it is not binded, so n is infinity, and infinity to the principal quantum number means where the nucleus is not, means not in the first energy level, nucleus or just suppose, so the n will be 0. So if the n is equal to infinity, then it is known as ionized hydrogen atom. What is known as ionized hydrogen atom? When the electron is attracted by the nucleus and is present in the orbit, then the energy is emitted. When the electron is attracted by the nucleus, as you know very well, electrons are attracted by the nucleus because electrons are negative charge and protons are positive charge. So definitely electrons will be attracted. So if we talk about this ionized hydrogen atom, so the electron will be attracted by the nucleus and it will be present in the orbit n, and the energy will be emitted. So here there is a question, what does the negative electronic energy En for hydrogen atom means? Very important question. See, each and every part of NCERT we must read. We must not leave a single concept, because as we get a concept, that time we should read everything. So let's start. What does the negative electronic energy En for hydrogen atom mean? as the energy of the electron in a hydrogen atom has a negative sign for all the possible orbits. All the possible orbits mean, you can see here in this equation, En is equal to minus RH 1 upon n square, where n is equal to 1, 2, 3. Here, are you seeing this equation? En is equal to minus RH into 1 upon n square, where n is equal to 1, 2, 3. So here what I want to say, as it is just informed you in this equation, what does this negative sign convey? The negative sign means that the energy of the electron in the atom is lower than the energy of free electron at rest. Means wherever the electron should be there, as for example, just suppose the electron should be there in the second orbit, but as the electron should be in the second orbit in the free state, but it is in the first energy level. So that time a free electron at a rest is an electron that is indefinitely far away from the nucleus and is assigned the energy value of 0. So first of all, read this concept. The negative sign means that the energy of the electron in the atom is lower than the energy of free electron. Lower than the energy of free electron. What does it mean? Means wherever it should be, it is lower than that also. At rest. At rest, not at the stationary, at the rest. So here, a free electron at rest is an electron that is infinitely far away from the nucleus and is assigned the energy value of 0. Mathematically, this corresponds to the setting n equal to infinity in the equation, as definitely as we were having energy En is equal to minus RH into 1 upon n square. If you will just put here E infinity, what will be the value? E infinity is equal to minus RH into 1 upon infinity square. So the value will be 0, right? So here you can see E infinity is equal to 0. As the electron gets closer to the nucleus, as the electron gets closer to the nucleus, the n will decrease. Definitely n will get decreased, then only it will come closer to the nucleus. So En becomes larger in the absolute value and more negative. More and more negative. En becomes larger in absolute value and more negative. The most negative energy value is given by n is equal to 1, which corresponds to the most stable orbit. We call this as the ground state. First of all, try to understand what the concept wants to say. Why it is termed as the negative sign in the hydrogen atom. Means why negative sign convey. So as we have seen, wherever the rest position it should be, it is lower in, as compared to that energy state, it is in the lower state, as the mathematically, since all the nucleus are assigned to the energy value of 0. So definitely if we talk about the infinity energy state, so E infinity will be also 0 and it will come closer to the nucleus. As it becomes larger and larger, more absolute value, it will be more negative. So can you tell me which is the most stable orbit? If anybody will ask you, then you have to just reply the ground state. When the n is equal to 1, that is the most stable ground state. Understand? Means any element's ground state. If I talk about the sodium atomic number is 11. 2p63s1 is the electronic configuration. So 3s1 is the ground state of sodium. Are you getting or not? Now let's go ahead. Now you can see here, and its energy is lowered. Whose energy is lowered? As you can see, as we have read here previously about this C concept, the most important property associated with the electron is the energy of its stationary state. En is equal to minus RH into 1 upon n square, where n is equal to 1, 2, 3. Means according to the Rydberg constant, E1, E2, E3 as the value, and the energy is lowered. This is the reason for the presence of negative sign in equation, and depicted its stability relative to the reference state of 0 energy and n is equal to infinity. Bohr theory can also be applied to the ions containing only one electron. Means any element is there, but the last electrons must be one. As for example, if I talk about helium plus means one electron. Lithium 2 plus, that also one electron. Beryllium 3 plus, that also 1 electron. Boron 4 plus, that also 1 electron. So Bohr theory can also be applied to the ions containing only 1 electron, similar to the parents, so similar to the present in the hydrogen atom. For example, helium 2 plus, lithium 2 plus, beryllium 3 plus, and so on. The energies of the stationary state associated with these kinds of ion is known as hydrogen-like species. What is that known as? Hydrogen-like species. And the expression En is equal to, you can see this expression, En is equal to minus 2.18 into 10 to the power minus 18 Z square upon N square. If anyone will ask you what is Z and what is N, so here Z means atomic number. As you can see, helium atomic number is 2. Are you getting or not? Helium atomic number is 2. And what will be the N? Energy levels. Okay, what will be the N? Energy. So here En is equal to minus 2.18 into 10 to the power minus 18 into Z square upon N square Joule. And the radii, as you will get, what will be the value of radius? So the radii will be 52.9 into N square by Z. 52.9 N square by Z, and it will measure in picometer. Z is atomic number and has the value like, if I talk about the helium 2, lithium 3, and these atoms, from the above equation it is evident that the value of energy becomes more negative and that of the radius becomes smaller. Value of energy become more negative, the radius will become smaller with increase of atomic number. So you can see here, as the atomic number will increase, because we are in the first energy level, so as the atomic number will increase, the radius will become more smaller. Why? Because here the energy level is 1. This means that electron will be tightly bound to the nucleus. Means, as for example, just suppose helium plus, as I have talked to you. So helium was having 2 electrons, I have removed 1 electron, I have make it like hydrogen-like species. So the nucleus will be tightly bounded with that helium's first electron. Similarly, in the lithium 2 plus, that will be tightly bounded towards the nucleus. It is also possible to calculate the velocity of electrons moving in these orbits. Although the precise equation is not given here, quantitatively the magnitude of the velocity of electron increases with increase of positive charge of the nucleus and decreases with the increase of principal quantum. Means, as the principal quantum number means number of orbit will be increased, the magnitude of positive charge on the nucleus will be decreases with increase in principal quantum number. So now this was the theory and the Bohr's hydrogen model concept. Now explanation of hydrogen line spectrum, means line spectrum of hydrogen atom. What is the line spectrum of hydrogen atom? If anyone will ask you, no need to worry. Here the line spectrum observed in this case of hydrogen atom, as mentioned in the section you can see here, it can be explained quantitatively by using the Bohr's atomic model. As in the second, as you can see the B option, what we have read in the B option, we have read about the n square E naught, right? What will be the radius, and here En is equal to minus RH into 1 upon n square. So here that according to the second assumption, radiation energy is absorbed if the electron moves from the orbit of smaller principal quantum number to the higher principal quantum number orbit. Whereas the radiation is emitted if the electron moves from higher orbit to the lower orbit. The energy gap between the two orbits is given by the equation delta E is equal to E final minus E initial. You know very well, definitely, as the electrons get energy, as it absorbs the energy, it will jump from lower energy level to higher energy level. If the electrons will emit the energy, again it will jump from higher energy level to lower energy. So there will be an energy gap between the two orbits, right? So the energy, how much energy will be there? Means the final energy minus the initial energy, whatever the electrons was having at initial, and as it had jumped to the higher energy level, means final energy level. So final minus initial, delta E is equal to EF minus E1. As you can see this concept, EF minus E1. Now here you can see delta E is equal to, if I talk about here, already I had explained you in the second, Bohr postulates of that hydrogen atom, he had informed the delta E is equal to minus R into 1 upon n square, right? So here minus RH into 1 upon nf square means final square, higher energy state, minus lower energy state, minus RH upon 1 upon n initial square. Nf means here higher energy state, and n initial means lower energy state. Ni and Nf stand for initial orbit and final orbit. So what will be there? Here minus minus will be plus, here minus minus will be plus. So we will take here RH by n1 square and minus RH by nf square. RH will take common, 1 upon ni square minus 1 upon nf square. N1 means initial and f means final. So here the value, after putting the value of this Rydberg constant, 2.18 into 10 to the power minus 18 joule into 1 upon ni square minus 1 upon nf square. The frequency associated with the absorption and emission of the photon can be evaluated by using the equation. As all of us know, E is equal to h nu. So what will be the value of delta E? Delta E will be also equal to h nu only. So nu will be delta E by h, right? And we have just found the value of delta E. You can see the value of delta E is, what is the value? 2.18 into 10 to the power minus 18j into 1 upon n1 square means n initial square minus 1 upon n final square. So after putting the value means frequency equation, in the frequency equation, so we have already seen delta E is equal to h nu. So nu will be delta E by h. Delta E value is 2.18 into 10 to the power minus 18, or you can take this equation also, RH into 1 upon n1 square minus 1 upon nf square. So, and what will be the value of Planck constant? Planck constant value is 6.626 into 10 to the power minus 34 joule second. RH value is 2.18 into 10 to the power minus 18 joule. So here you can see 2.18 into 10 to the power minus 18 joule upon 6.626 into 10 to the power minus 34 joule into 1 upon n initial square minus 1 upon n final square. After dividing 2.18 upon 6.626, you will get the value here 3.29 into 10 to the power 15. Here 34 minus is there, it will go up. So the value will be 3.29 into 10 to the power 15 into 1 upon n initial square minus 1 upon n final square. Since the SI unit of frequency is hertz, so the unit will be hertz. Now the wave number. What is wave number? Wave number is equal to 1 upon lambda. And what is the value of lambda? Lambda is equal to c upon nu. So nu will go up and c will come down. So wave number is equal to nu by c. Right? So here we have already calculated the value of nu. You can see the value of nu. And c is equal to, what will be the value of c? 3 into 10 to the power 8. So you know very well, after getting the value of nu, here you can see nu value is 3.29 into 10 to the power 15. So 3.29 into 10 to the power 15 into 1 upon n initial square minus 1 upon n final square, and the c value is 3 into 10 to the power 8 meter per second. Leave this equation just. After getting this equation, divide this 3.29 by 3. So you will get 1,09677 into 10 to the power 7 into 1 upon initial square minus 1 upon final square. In the case of absorption spectrum, remember this word, as already I have talked about the negative things. So here, why the hydrogen value is negative? So here just listen this concept. In the case of absorption spectrum, n final will be greater than n initial. Case of absorption means when it will jump from one energy level to the higher energy level. So in the case of absorption spectrum, n final will be greater than n initial, and in the term of parenthesis is positive and the energy is absorbed. And on the another hand, the case of emission spectrum, emission means when it is coming from higher energy level to lower energy level, that time n1 will be greater than n initial, will be greater than n final, and the value of delta E will be negative because the energy is released, right? So as it was expressed in that equation is similar to used by Rydberg constant, derive the empirical using the experimental data available at the time. Further, each spectral line, whether in absorption or emission spectrum, can be associated to the particular transition in hydrogen atom. In case of large number of hydrogen atom, different possible transition state can be observed. and thus leading to a large number of spectral lines. The brightness or intensity of the spectral lines depends upon the number of photons of same wavelength or frequency absorbed or emitted. What does it mean? As already I have told you about the transitions of hydrogen atom. As the hydrogen atom will get, as it will absorb the energy, it will jump from lower energy level to higher energy level, means transitions of electrons in the hydrogen atom, and as they will emit the energy, it will come back to the higher energy level to the lower energy. So the spectral lines are produced as according to the brightness or intensity of the spectral lines will be depending upon the number of photons of the same wavelength. Frequency is either absorbed or emitted. Now come here, there are some questions. As we have already seen about the formula of delta E. What is the value of delta E? Delta E is equal to 2.18 into 10 to the power minus 18 joule into 1 upon n1 square minus 1 upon n2 square. Right? Here there is a question. What are the frequency and wavelength of a photon emitted during a transition from n is equal to 5 state to the n is equal to 2 state in the hydrogen atom? Means from, you can see here, what will be the value? First of all, listen, it is coming from higher energy level state to the lower energy state, so the value will be in negative, right? As already explained. So here you remember the answer will always come in negative. Second thing, you have to nothing here, n1 value is 5 and n2 value is 2. You have to just keep on the formula delta E is equal to 2.18 into 10 to the power minus 18 into 1 upon n1 square minus 1 upon n2 square. So n initial 5 and final 2. So 1 upon 25 minus 1 upon 4. 25 and 4 LCM 100. So you know very well. 25 4s and 4 25. 4 minus 100. So 96 upon 100. So after multiplying and dividing, the value will be minus 4.58 into 10 to the power minus 19 joule. It is an emission energy. Why? Because it is the negative sign. It is coming from higher energy level to the lower energy level. So that's why, which type of energy is this? This is emission energy. And the frequency of the photons taking energy level. You have got the value of delta E, and you know E is equal to h nu. You have to calculate the value of nu. So nu will be delta E by h. The frequency of the photon by taking energy in the terms of magnitude, nu is equal to delta E by h. So delta nu value here already you have calculated, minus 4.58 into 10 to the power minus 19 joule, and h is Planck's constant 6.626 into 10 to the power minus 34 joule second. Joule cancel, second inverse answer will be in the second inverse or hertz, since we are calculating the frequency. So the frequency value, after dividing the value, you have got it 6.91 into 10 to the power 14. You know very well, lambda is equal to c by nu, because the speed of light was the product of wavelength and velocity, frequency and wavelength. C was equal to the product of wavelength and frequency, so wavelength will be c by nu. What is the value of c? Speed of light 3.0 into 10 to the power 8 meter per second, and here nu value already you have calculated 6.91 into 10 to the power 14 hertz. After dividing this, since lambda wavelength, it is length, so you will get here the value. It was meter, right? And if it comes into 10 to the power minus 9, it will convert it into a nanometer. So 434 nanometer. Are you understanding the concept? See, remember, there is only one thing. What you have to do, you have to just understand the formula concept. After getting the formula concept, you can easily solve the numericals. Main thing, what are the things given in the numerical? First of all, write that, and after then what they are asking and which formula suits to the numerical. Here there is one more numerical you can see here. Problem 2.11. Calculate the energy. What we have to calculate? E. Associated with the first orbit of helium plus. First orbit of helium plus. What is the radius of this orbit? You have to calculate radius, means R you have to calculate. First of all, energy you have to calculate. According to the formula, you have to remember, minus RH into Z square upon N square, and after putting the value of RH 2.18 into 10 to the power minus 18. So minus 2.18 into 10 to the power minus 18 into Z square upon N square. That is the value of En. So helium plus. What will the value? Helium plus. Electron will be in the first orbit. Atomic number is 2. So E1 is equal to minus 2.18 into 10 to the power minus 18 into Z. Z means atomic number. Atomic number of helium is 2. 2 square upon electrons is in the first orbit. So the value of N is equal to 1. So 4 into 2.18, that is equal to minus 8.72 into 10 to the power minus 18 joule. This is the value of E1. Now the radius of the orbit, you know very well, formula was Rn is equal to 0.0529 upon Z nanometer into n square. Now here value of n is 1, Z value is 2. Now just put the value in this formula. Rn is equal to 0.0529 into n value is 1, so 1 square, and the Z value is 2. After calculating the value, you will get the answer 0.02645 nanometer. So just understand the concept by which formula what you will get. Easily you can solve all the numericals. Here the question was about the energy. First of all, energy state. So you must remember this formula. After understanding this formula, they were asking about the radius. Radius formula is this: Rn is equal to 0.0529 into n square by Z nanometer. So here, after understanding the concept, you must solve 2-3 numericals. Just suppose in your mind, if there is a question about the lithium 2+, okay, lithium 2+, lithium atomic number is 3, so the value of Z will be 3 and n will be 1. Why? 3 plus means total 1 electron. The 1 electron will be in the first orbit, so you can take. After understanding this concept, now here what are the limitations of Bohr model? Limitations means demerits. What are the demerits of Bohr model? What Bohr had not explained. Bohr model of the hydrogen atom was no doubt an improvement over Rutherford's nuclear model. It could account for the stability and line spectra of hydrogen atom and hydrogen-like ions like helium plus, lithium 2+, beryllium 3+, and so on. However, the Bohr model was too simple to account for the following. Means, if we compare the Rutherford and Bohr, then Bohr had done too much. But each and every scientist leaves some defaults, right? So now question that what he had not given in his postulate. It fails to account for the finer details, that is too closely spaced lines of the hydrogen atom spectrum observed by using sophisticated spectroscopic techniques. This model is also unable to explain the spectrum of atoms other than the hydrogen. For example, helium atom, which possesses only 2 electrons. Further, Bohr theory was not able to explain the splitting of spectral lines in the presence of magnetic field, that is Zeeman effect, or electric field, that is Stark effect. Remember this word. Since Bohr had calculated only for the hydrogen atom, so they were not able to explain even about the helium also, and they are not able to explain about the spectral lines which are present in the magnetic and electric field. The spectral line present in the magnetic field is also known as Zeeman effect, and the spectral line present in the electric field is known as Stark effect. This thing we'll read in the chapter number 4, chemical bonding. Now, the second drawbacks of Rutherford was it could not explain the ability of atoms to form molecules by chemical bond. Means Rutherford was really why chemical bond happens or why atoms bind with each other. He was not able to explain in his postulates. So it could not explain the ability of atoms to form molecules by chemical bonds. In other words, taking into account the point mentioned above, one needs a better theory which can explain the salient features of the structure of complex atoms. Means remember, each and every scientist, after giving the concept, they leave some of the drawbacks or they leave some limitations. So the new scientists take up on and they revise their concept. Now there are the two main concepts towards the quantum mechanical model of the atom. In view of the shortcoming of Bohr's model, attempts they were made to develop more suitable and general model of atoms. Two important developments which contribute significantly in the formulations of model were dual behavior of matter and Heisenberg uncertainty principle. See what the Bohr could not explain here, it's already written. These two things, both the natures of matter, means particle nature and wave nature. And second thing, Heisenberg uncertainty. What is Heisenberg uncertainty principle? He had just told, at the same time you can't calculate the position of an electron and P is equal to mv. You have heard about that. That was linear momentum. So here you can see, as he had just informed about, you can't calculate the product of, means momentum and the position at the same time you can't calculate. That concept was given by Heisenberg. So first of all, let's read about the dual behavior of matter. What are the dual behavior of matter? There was a French physicist. He was from France, French. So his name was de Broglie. In 1924, he has proposed that matter like radiation should also exhibit dual behavior. Means matter has both the nature. Both nature means both particle and wave-like properties. This means that just as the photon has momentum, as well as the wavelength electron should also have momentum. Are you understanding now? As you have seen in the photoelectric effect, the number of electrons are ejected. Similarly, as here you have told about if the wave is having the properties, which means the particle as the dual behavior nature, if a matter is having a property of wave-like and party-like both, means the photon has momentum. Similarly, the wavelength electron should also have momentum. And he have momentum as well as wavelength. De Broglie from the analogy gave the following relation between the wavelength and moment. After then doing the research between the concept of wavelength and momentum, the material particle or wave particle, he had just given his concept. You can see here the person known as de Broglie. See, all the scientists were very much interested. They find something and they have given the concept. So Louis de Broglie, a French physician, studied the history as undergraduate in the early of 1910. His interest turned to science as a result of his assignment to radio communication in the World War I. He received his doctor scientist from the University of Paris in 1924. He was a professor of theoretical physics at the University of Paris from 1932 until his retirement in 1962. He was awarded the Nobel Prize in Physics in 1929. You can just see his basic background. The person who was graduate with history, as after getting the interest in science, he have taken a scientist degree, PhD, everything he had done from this physics. Now come to the point. As he had given the relations between H is equal to, see here, first of all, remember that formula. Which formula? Momentum formula. What is momentum? P is equal to product of mass and velocity, mv, right? Here lambda is equal to h by mv. Now you can ask me, sir, from where this formula came? Lambda is equal to h by mv. You have earlier calculated the formula concept. You have earlier calculated about the nu. Have you remembered in the previous section of this lecture? As already I have told you, from that only we have taken the lambda. Lambda is equal to h upon mv. As he had given the relationship between the lambda and momentum. So lambda is equal to, lambda was inversely proportional to momentum. M is the mass of a particle, V is the velocity, and P is the momentum. De Broglie prediction was confirmed experimentally when it was found that an electron beam undergoes diffraction, a phenomenon characterized of waves. This fact has been put to use in making an electron microscope, which is based on the wave-like behavior of electrons. Just as an ordinary microscope utilizes the wave nature of light, an electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. It needs to be noted that according to de Broglie, every object in the motion has a wave character, and the wavelength associated with the ordinary object are so short because of the large masses that their wave properties cannot be detected. The wavelength associated with the electrons and the other subatomic particles with very small mass can however be detected experimentally. Results obtained from the following problem prove the points quantitative. See, this de Broglie had just given the concept about that each and every matter has both the properties, wave-like nature and particle-like nature. But some of the objects are very big, so they do not show this property. So that's why when we talk about the small particle like subatomic particle, so after getting from the experiment, they have given this theory. So here What will be the wavelength of a ball of mass 0.1 kg? M value is 0.1 kg and V value is 10 meter per second. Right now only we have just taken a theorem, lambda is equal to h by mv. So according to the de Broglie equation, lambda is equal to h by mv. The value of h, Planck constant, 6.626 into 10 to the power minus 34 joule, and mass 0.1, V is 10 meter per second. So here just 0.1 upon means 1 by 10 into 10 cancel, 6.626 into 10 to the power minus 34 meter, because lambda SI unit is meter. The second question you can see, the mass of an electron is 9.1 into 10 to the power minus 31 kg. If its kinetic energy is 3 into 10 to the power minus 25 joule, calculate its wavelength. What are given? ME, mass of electron, and kinetic energy. What you have to calculate? Wavelength. Before calculating the wavelength, you should remember about the formula. Kinetic energy is equal to half mv square, right? Kinetic energy is half mv square. So here kinetic energy value is given, m value is given. First of all, calculate the v value, right? So v square will be 2 kinetic energy upon m. So v will be under root 2 kinetic energy upon m. After calculating the value, you will get 812 meter per second. Now lambda is equal to h by mv. H means Planck constant, m is already given, and v you have calculated. So after doing the calculation, the answer will be 896.7 nanometer. Now calculate the mass of a photon with a wavelength 3.6 angstrom. Mass of a photon you have to calculate. Lambda value is given 3.6 angstrom. Convert this angstrom into meter, 10 to the power minus 10 meter. Velocity of photon is equal to velocity of light. Velocity of photon is equal to velocity of light. You have to calculate the mass. So m is equal to h by lambda nu. Right? Right now what was the formula? Here you can see lambda is equal to h by mv. So m will be h by lambda nu. H is Planck constant. Lambda is 3.6 into 10 to the power minus 10, and nu means speed of light, because velocity of photon is equal to velocity of light. So 3 into 10 to the power 8 meter per second, that is 6.135 into 10 to the power minus 29 kg. So this was our today's concept. As next postulates about the Heisenberg uncertainty principle, I'll explain in the next video. I hope that whatever the concept I had explained, you must write this concept into the mind. See, the main thing is what you have to understand the concept. Rest everything is present in your assignment, your notebooks, your textbooks, your reference book, everything is there. You must understand the concept. After understanding the concept, easily you can solve all the numericals. I hope all of you have liked this video. If you have enjoyed this video, then please like and subscribe the channel. Don't forget to share this video with your friends so they can be also benefited. Thank you very much.